Hi everyone, I'm Jeremy Simon with 3D Universe, and I'm pleased to welcome you back to another episode of 3D Universe Untethered. This is episode number 14. This one's going to be a little bit different. Normally we have guests with us and we get to sit down and talk with them about the exciting things they're doing with 3D printing, and we like to share those kinds of stories and experiences with you. Today is going to be a little bit more of an information dump. This is going to be an episode all about 3D printing best practices and answering your questions. So over the last several weeks, we've invited you, our customers and community, to share your questions about 3D printing, and I'm going to do my very best to answer all of those during this session. Now, having said that, we have an hour here. So I already know we're not going to get through everything I'd like to get through. You just can't talk about everything there is to talk about with 3D printing in an hour. So I'm going to do my very best to touch on a lot of ground. I'm probably not going to go too deep into any of it. I'm always happy to follow up via email or do follow-up videos to address some of these topics in more depth. But I am going to try to address all of the questions that I received over the last several weeks at some level. And so I expect this is going to be geared towards mostly people that are getting started with 3D printing, but also people that have been 3D printing for a while. My goal here is to give even the more advanced users at least one or two things that maybe you didn't know before and that might save you time going forward, either as a result of not having to redesign something or not having to redo a failed print. And if I can do that and save you at least an hour going forward, well then I will have made your time here well spent. So that's my goal. Having said that, I'm going to go ahead and pull up some slides to get started, just to kind of keep me on track here. I'm going to use that to kind of go through this range of topics that I want to be sure I touch on, just kind of cover all the basics about 3D printing and what you should be thinking about as you go through this process. And then we'll switch over and I'll pull up a slicing program and we'll do more of an interactive demo kind of a thing, and we'll look at some of those concepts that we talked about. And while I'm doing all of this, I want to encourage everyone, as always, to continue to share your questions and comments. If you're watching this on Facebook Live, you can just post a comment there on the Facebook Live page, and I will see those. Now, the difference today, since I'm the only one doing this session and I'll be in presentation mode, I might not see those comments until I finish with the main presentation. So we'll come back to those at the end, and I'll be sure to address any questions that come in along the way. All right, having said that, I'll just remind you that you can always find information about this series and any recordings and related links, that sort of thing. If you go to our blog, 3duniverse.org, you'll see the graphic in the upper left corner for 3D Universe Untethered. Click there, that'll take you to the page that has everything you need to know. With that, I'm going to go ahead and pull up the slides here. Let's see. Okay, now hopefully you are seeing this full screen with me up in the corner. So I'm going to move pretty quickly here, but again, I want to just kind of take a broad pass across a lot of ground here. So starting with just talking about the basic 3D printing workflow. Starting in the middle of this graphic, you have an idea for something that you want to 3D print, okay? Well, the first thing you want to think about is, what are the requirements of this part that you have an idea for? Does it need to be particularly strong? Does it need to be flexible? How is it going to be used? Does it need to hold up in a certain kind of environment or certain kinds of conditions? Will it be exposed to chemicals? These kinds of questions and this kind of thinking will lead you towards an idea of what sort of material you'll be using. And the material choice actually can influence how you design the part. So that's why you want to think about this first. Once you have an idea of the kind of material you're likely to use, and you go into the sort of the design, the 3D modeling phase, now you can build a part with that in mind, based on how that material works, how that material maybe flexes or doesn't flex, that kind of thing. Prepare that model for 3D printing. That's using the slicing software, and we're going to take a look at that today. I will mention, by the way, going back a step, you can use any kind of CAD software you want for this 3D printing workflow. Doesn't matter what kind of 3D printer you have, for the most part, you can use the CAD software of your choice. You can use basic free programs like Tinkercad online, which is wonderful. It's amazing what you can do with it, even though it's free and considered fairly basic. You can go to more advanced programs like Autodesk Fusion 360, which is the one I like to use, or SolidWorks, or so many others. Whether they be commercial or free or open source, doesn't matter. There's lots of choices out there, and they will all work fine. When you're done with your modeling, you just export in the STL file format. That's pretty much the universal file format for 3D printing, and that's what you bring into the slicer software, and that's what's shown here in the step on the right at what would be sort of 3 o'clock. Now, in the slicer program, you're going to set all your settings. This is where you tell it how you want the object to be printed. How solid do you want it to be? How much of the insides do you want to be just a sort of a grid pattern versus solid? How thick do you want the walls to be? How thick do you want each layer to be? There's all kinds of settings, and we'll look at some of those. But the point is, you don't need to worry about that during the CAD phase, okay? When you're designing your objects, they're just going to be solid bodies. If you create a cube, that's a solid cube that you created in your CAD. Whether or not it gets printed solid, that gets determined in the slicing step, okay? So you don't have to worry about how it's going to get printed when you're in the CAD software. All right, so you go through the slicing, you pick your settings, you get it all ready, you send it to the printer, and you 3D print. You let the printer do its work. Hopefully that goes smoothly. When it's done, there might be some kind of post-processing. It depends on what you're dealing with. For example, nowadays, a lot of people have printers with dual extrusion capabilities, and they sometimes print with soluble support material, so that if the object needs to be printed with supports, and we'll talk about that shortly, you can print with a type of support material that can be dissolved in water. So you might have to drop your part in water after it prints to dissolve away those supports. There's other kinds of post-processing that may be involved as well, depending on what you're doing. Some parts can be annealed by putting them into a certain temperature environment, like a low-temp oven for a period of time, and that sort of gives them an additional level of strength and temperature resistance. So there's various types of post-processing that you might need to do based on, depending on what you're trying to accomplish. And then you test your part, you use it, you see how it works. Did you get it right? Usually you don't. Usually you find that on the first try, it didn't come out quite the way you wanted. And so you'll find that this is an iterative process. You'll go ahead and go back to the drawing board. You'll fix something. You'll figure out, was it too big? Was it too small? Did it flex too much? Did it break when I put too much stress on it? And you make adjustments accordingly. And then you go back to through the same process. And that's why, aside from having the initial idea, this is really just a cyclical process. You continue to go through that cycle as you iterate. So that's the basic workflow, and we're going to be talking about a lot of the aspects, not all aspects of that, but a lot of it today. So one of the questions that came up is, how do I get my models? Not, the basics, there's a number of different ways, and most of you are probably familiar with the basic options. You can make your own, obviously, and this is one that I hope that you will all explore. Some people are a little bit shy about this. They get a 3D printer and they start downloading things from Thingiverse. That's the second option here. You can go to sites like Thingiverse or Umagine or My Mini Factory. There's all these different sites out there where you can download models, and there are so many. I mean, I used to say hundreds of thousands. There's got to be millions now. There are so many out there that pretty much anything you search for, you'll find. You can just download it, and you can 3D print it, and you can have all kinds of fun. But eventually, you're going to get to a point where you start to think, I'd really like to make something of my own. I'd like to create something from scratch. And that's where you start to learn a little CAD. And once you've created your first object in CAD and 3D printed it, and you're holding it in your hand, something that you created, there's nothing like it. There's no going back. So do explore that. It's not as hard as you would think. There's some really easy to use CAD programs out there. But you can download models. Another option is sort of a hybrid. You can download a model and then you can modify it. So somebody asked, how do I do that? What if I see something on Thingiverse that I want to download, but I want to make changes to it? Check out a program called Autodesk Mesh Mixer. It's a free download. Anyone can download this. And I'll show you that probably later when we get into the demo phase today. I'll show you that tool, and it's a wonderful tool for editing meshes. That's what STLs are. So when you do your CAD work, you're creating solid body objects, and that's at that phase you're working in a CAD format. It depends on what program you're working in. But then when you export it to STL, you're turning it into what's called a mesh file. It's a different type of 3D file that's made up of a whole bunch of little triangles that sort of approximate the surfaces and the shape of this 3D object. Well, Mesh Mixer is exactly as the name suggests. It's a mesh editor. So it's designed for manipulating meshes. It has tools for, smoothing parts of it or causing parts of it to bulge out or slicing parts of it. You can merge two different meshes together. So if you want to take the head of one, model and merge it onto the base of another model, things like that, you can have all kinds of fun with something like Mesh Mixer. But even for just basic things, if you have a model that's maybe too big to put on your printer, you can slice it in half or slice it into pieces and then use separate files to print it in pieces and reassemble it afterwards. So Mesh Mixer, very helpful and free tool. You can also use a 3D scanner. They are becoming more widely available and more affordable. They even have fancy little scanners that you can attach to your iPad. I use one of those from Occipital called the Structure scanner, structure.io. And they've got, the latest model of, iPhone has a sort of a LiDAR-based scanning capability. So there's all kinds of options for 3D scanning, and then you have more advanced types of 3D scanners available. So you can 3D scan a person or a head or a part or an object, whatever it is that you want to capture, whether it be smaller or larger. There's different types of scanning solutions for those. You may need to do a little bit of cleanup on it before you 3D print it, just to clean up the scan mesh a little bit and remove any unwanted bits. But then you can sort of clean it up and you can 3D print it and essentially make copies of that object for yourself. It's also helpful to use a 3D scan as kind of a reference to then build your own clean 3D model around. So you can 3D scan something and then just use that to build your own model around, so you have nice clean surfaces and clean geometry that you can use instead of relying on that mesh. So lots of ways of getting your 3D models. Let's talk a little bit about hardware. There's a lot to talk about. Again, we're only going to scratch the surface here, but briefly we'll touch on the different types of 3D printers that are out there. Some people ask, well, what should I be looking at? Do I want an FDM printer? Do I want SLS? Do I want SLA? And that's not it. I mean, there's multi-jet fusion, and there's lamination machines. There's all kinds of different 3D printers out there. I'll tell you right now, most of what we're talking about today is FDM, but I'll just touch on these three, which are the most common here. So FDM works by extruding melted thermoplastics into layers. Extrudes out a nozzle, and it sort of paints layer by layer, puts out a layer, moves up a little bit, builds a layer, moves up a little bit, builds a layer, and so on. So you're building up from the build surface, and that's the one that most of you are probably used to. It's affordable, it's accessible, it offers the widest variety of materials. As long as you have a heated bed, you have a huge array of materials to choose from, which is one of the, I think, biggest reasons that this is the type of 3D printing most people gravitate towards. Then you have SLS. SLS stands for selective laser sintering, and this is using a laser to sinter layers of powdered medium. Usually it's a nylon, but not always. And it basically melts that material in a layer, and then it'll sort of sweep a new layer of powder over the top, and then sinter another layer, and then sweep a clean layer on top of that. And the result is that as your object is being built up, it's actually being encased in this powder, the stuff that hasn't been sintered. It's sort of enclosing your object, so it's fully supported as it prints. So you don't need the type of supports you deal with FDM printing, which we'll talk about later. But it does have some cons to it as well. They tend to have kind of a rough surface when they come out. It's not like a smooth finish. Might not be the best for moving parts and that kind of thing. There is some post-processing involved. You need to have sort of machinery for that cleanup process and getting rid of all that powder in a way that stays in an enclosed environment. And for that reason, they tend to be pretty expensive. These printers are not the kind of thing you'll typically see in an individual's home. SLA stands for stereolithography, and this is something that you might see in someone's home. It's becoming more and more popular. This is a resin-based printer. So you have a vat of liquid resin, and that resin is photosensitive. And so from underneath, there's a light source. These days, it's mostly things like LCDs or DLPs, where you can expose light to the underside of that liquid, and you sort of expose a shape to it, and it cures the resin in that shape, and that's your layer. And then the build plate lifts up a tiny bit, and it cures another layer, and so on. And so with these printers, your object is sort of lifting out of the vat of liquid, albeit very slowly. Instead of building up from the build plate, it's sort of lifting out of this pool of liquid. Very cool. It is unique in that they produce exceptionally high quality prints. I mean, you cannot get the level of detail that you get on an SLA printer from an FDM printer. It's just not possible when you're sort of pushing around melted plastics. But with this, you're using light to cure a resin, which gives you a much higher quality level of detail. They have, however, pretty few materials to choose from, at least comparatively speaking. It's getting better. There are more and more SLA resin materials coming to the market. You can now get tough resins and high temperature resins and flexible resins and things like that. But for the most part, they're kind of purpose specific. There's kind of a small group of resins that are designed for certain use cases. It's not like filaments for FDM printers where you just have hundreds and hundreds and hundreds to choose from. So for the most part, FDM is the most common because of that versatility and affordability. And so the rest of today, we're pretty much going to be talking about FDM printing. All right, Determining which materials you can use. Now, this is really important. If you haven't bought your printer yet, the one thing I hope you get more than anything out of this is make sure you get a heated bed. People might not realize how much of a limiting factor not having a heated bed can be. If a printer doesn't have a heated bed, it's pretty much designed for just printing PLA. Maybe tough PLA, maybe TPU, because those materials don't really need the heat for it to stick well to the bed. But pretty much any other material you're going to have a hard time with. All those more advanced materials are going to be out of bounds for you. So a heated bed, in my mind, is a must-have. Try to avoid the mini type 3D printers unless you absolutely know that you only need to print really small things. But having a larger build volume, not huge, but a typical, let's say 8 by 8 by 8 inches or better, is going to give you just so much more flexibility. And you'll probably use it. You're going to find things you can do that you didn't think of before you bought this printer. So give yourself the extra room, give yourself the extra opportunities to play with other ideas. A direct drive extruder, what this means is that the mechanism that pushes the filament down to the hot end is right next to the hot end, so that the gears that grab that filament and push it are positioned, just an inch or two away from the nozzle that's getting hot. So it doesn't have far to push the material, and so you don't have to worry about it getting all bent up and that sort of thing. Some printers use a Bowden tube that extends from somewhere else on the machine to push that material through to the hot end, and there it gets melted. And so you will, sorry folks, I've just been informed I'm having some video issues here. Let me see if I can. There we go. USB cam issues. Let's see. So, you want, for flexible materials, if you're trying to push it through this long tube, it can kind of get bunched up. It's going to be a lot trickier. It might be doable, but it's not nearly as easy as it would be with a direct drive extruder. So keep that term in mind, direct drive extruder. If you see that, that's a good feature to have, especially if you think you'll play around with flexible printing materials. An enclosed build area might be beneficial. Really depends on what materials you're going to use. Some of the more advanced materials have a tendency to warp, and they'll tend to kind of lift off the build plate, especially at the corners, and having an enclosed build environment that'll keep that build area warmer makes all the difference in the world. Having said that, nowadays you have access to some wonderful adhesives that I'm going to touch on later, and those adhesives can also be a great way of dealing with those issues, and you might be able to print some of those materials without an enclosure, even if you might not have been able to without that adhesive. So I'll show you those in a bit. And then think about the nozzle size you end up using. Most printers let you choose between different nozzle sizes. You can kind of swap them as needed. Some printers, like Ultimakers, have a print core that you change out, which is kind of a cartridge that includes the nozzle and the whole hot end. But you can put in a smaller nozzle, like a 0.25 millimeter, for example, and you can print really fine details, but it's going to take longer to print because your whole object is going to be printed in thinner, smaller lines and thinner layers. So it'll take a lot longer. A 0.4 millimeter nozzle is what's considered sort of standard. That's your default. That's what most people use, and it'll work great for most prints. But you can also go up to a larger nozzle. You can go to a 0.8 or even a 1.0 or larger. They have very large nozzles. And so that if you don't care about fine details, and if you don't care about having visible layers, you just want to print something, maybe it's really large and you want to print it as quickly as possible, you can go to a larger nozzle and you can print much more quickly, because not only is each line wider, so you're putting out more material at once, but each line height, your layer height, can be thicker as well. So, and we'll talk about that a little bit more in a while. All right, somebody asked about full color FDM printing. Most of what we're doing is single color printing. You're putting one color of filament in, and you're printing an object in one color. More and more, you get machines nowadays, 3D printers, that have dual extrusion capabilities. So you could put in two colors of material, and you could print a two-color object. You have to have two different 3D files then, one for each color, that fit together. And I'm probably not going to get into that in detail today, but you can do two-color printing on a dual extrusion printer. But what about full color? What if you really wanted to have every color, like, when you use a color printer in 2D that we're used to being able to print out photos and whatnot? Well, actually, yeah, you can. It's already out there. I would say yes, but, because at least in my experience, they're not quite where I'd like them to be, to where I think they give you the same kind of smooth user experience that most 3D printers do. But I will say that there are some solutions, and they're getting better. There's a company called XYZ that has a line called the Da Vinci line, and they make a Da Vinci Color. It's a full color 3D printer. And what it does is it's basically using a typical FDM 3D printer head to print out a material in a single color that you're seeing there in white in the sample photo. And then it also has sort of an inkjet print head where it's literally using an inkjet style printing method to apply ink on the outside of the object as it goes layer by layer. So it's actually kind of a two-part process where it's printing the object and then it's coloring it using a standard kind of an inkjet process. So a pretty creative approach to full color 3D printing. And as you can see, you can get some pretty decent looking objects. It's relatively affordable. I did actually test this a long while back, and I found it, I was surprised at how large and heavy it was right out of the box. The picture there is a little deceptive, but you know, it's definitely an option that's available for you. Here's another way that you could do it. There's an accessory that you can add on to your existing desktop 3D printer that's made by a company called Mosaic. It's called the Palette 2. And this is something where you feed multiple strands of filament into it. So you can feed up to 4 different colors of filament into this gizmo, and it sort of merges them inside and allows you to do full color printing by switching between or merging between these different colors. And as you can see in the sample there, you can do multicolor printing. So you can do, you know, you can have up to 4 different colors in a single print using that kind of a mechanism. And then you have really expensive solutions that I don't have a lot of experience with, and so I'm not going to be getting a lot into this. The picture here is a multi-jet fusion machine from HP. This is one that it uses a lamination process. It's pretty cool. They basically take sheets of paper and they're cutting the sheet of paper to the shape of the layer of the object, and then they're gluing that sheet of paper, and then they're coloring around it using kind of an inkjet method, much like the Da Vinci. But they're basically building your object by stacking pieces of paper that are being cut out in the shape of the object. So you end up with the objects like you see there that can be pretty, pretty high quality, color 3D objects. So solutions are available. That's not going to be the focus of today, but if that's what you really are after, you can check into a couple of these solutions on the left. Another question that came up was, how long should I expect my X to last? One question was, how long should I expect my nozzles to last? Somebody asked how long I should expect my printer to last. How long should I expect, this or that component to last? The answer to all of these is really the same. It depends. I'm sure that's not surprising. And I'm not trying to be evasive here. It just really is, because there are so many variables involved here. What I can tell you is my experience has been that for the most part, a well-made 3D printer is really going to last a long time if you take care of it. I have printers here that I have been using heavily for 7, 8 years, and they're going strong. Sure, I have to do basic maintenance. I have to make sure that they're lubricated properly and that sort of thing, and I clean them occasionally. 1 or 2 of them I might have had to replace a part from time to time, but generally speaking, parts are easy to replace and not too expensive. So they last a long time as long as you take care of them. Nozzles and print cores, that kind of thing, that's going to be entirely dependent upon what you're using them for, how you're using them, what kind of materials are you putting through them, and again, how well you're taking care of them. It's a good idea to have kind of dedicated nozzles or dedicated print cores as much as you can for different materials instead of switching between materials with the same nozzle. Not necessary, but helpful. So if you can have one nozzle that you just use for your nylon prints and one nozzle that you use just for ABS and one that you just use for your PLAs, that helps. It's just going to make it easier. For example, if you've just printed something in ABS, that has a pretty high printing temperature. Say you unload that and then you load in a spool of PLA that has a much lower printing temperature. When it's trying to go through and push out the ABS that was in there, it's going to have a hard time because you're at a lower temperature. So it helps to have kind of dedicated nozzles or print cores for different materials. But they should last a long time. Having said that, I mean, again, I have print cores that I would say have well over 1,000 hours of printing on them. I would say you should expect definitely hundreds. And probably well over 1,000 hours if you take care of these things. Okay, materials. There are, as I said before, a lot of 3D printing materials out there. And I don't even know. I can't keep track of them because the new ones are coming every day. There's probably thousands of them out there now. This chart does a really nice job of summarizing them. This is courtesy of Ultimaker. If you look at the bottom tier that they call commodity thermoplastics, Those are very common materials. You've seen some of these on the right side. You have things like PLA and polypropylene, etc. Middle tier is what they call engineering thermoplastics, and we'll talk about some of these as well. You get into things like ABS and PETG and TPU here. And then you've got this upper tier, what they call high performance thermoplastics. These are generally the very high temperature materials like PEEK and PEC and PEI, things that the kinds of printers that I'm using and most of you are using just can't print these materials. It's out of the range of the printing temperatures we're dealing with. These are for the very high-end 3D printers that cost tens of thousands of dollars or more. So for the most part, our audience here will be dealing with those lower two tiers, and that's what we'll be talking about today. So even within that realm, those lower two tiers, there's an immense variety of materials to choose from, so we won't even be able to scratch the surface. I won't be able to touch on all these. I'll only touch on a couple of the more common ones here today, given our limited time. So PLA is by far the most popular, and I think there's good reasons for that. It's super easy to print with. It's widely available. It's extremely affordable. It's environmentally friendly. It's made entirely from plant-based materials. And as a result, it's completely non-toxic as a result. You do not need a heated bed for PLA. It's one of the very few materials that you can print on just about any printer. The cons, the reasons that it's not an ideal material in some cases, is that it can be a little bit brittle. I mean, it's a pretty strong material. It's solid, but it's brittle. It doesn't really have any give to it. And it also doesn't have a really good temperature resistance. So if you make a part in PLA and you leave it in in the back of your car on a hot summer day, you come back to that car, that part will be in a different shape. It will have sort of slumped and just melted down a little bit from the shape that you left it in. So not a good choice for environments that are going to have temperatures above room temperature basically. Then you have enhanced types of PLAs. You got tough PLA and PLA plus and high impact PLA and high temp PLA. There's all kinds of different enhanced PLAs coming on the market, and they have the same benefits: easy to print, widely available, they're inexpensive, they're still non-toxic, they're easy to, no heated bed required, etc. But then you get these benefits from the enhancements. Like a tough PLA can be 2 to 3 times stronger than normal PLA. A high temp PLA will, as the name suggests, give you a higher temperature resistance. Not as high as some of the other materials out there, but better than standard PLA. High impact PLA gives you, exactly as the name suggests, something that won't shatter, as easily, that's not as brittle. So there are enhanced forms of PLA that you can use that have really nice properties. Generally, the only property they don't have, that I have on the negative side here, is the temperature resistance, except for, as I mentioned, the high temperature PLA. So some nice options, and I definitely encourage you to look into the enhanced PLAs. They're really nice to work with, and they're generally not much more expensive than regular PLA. So these have become kind of my go-to for just kind of general printing. ABS, I would say, used to be a lot more popular when 3D printing really was getting going. At the desktop level, a decade or so ago, there was a lot more people doing ABS. Printers were kind of optimized for ABS, and it is a nice material. I mean, you get great impact and wear resistance. It's a nice, strong, this is what Legos are made out of. You guys are familiar with this material. You get a much better temperature resistance. Parts will hold up in higher temperatures. It's easily available. One of the things I like about ABS is that it can actually be post-processed using an acetone vapor treatment. You got to, of course, use appropriate safety measures, but this will smooth the outer surface by essentially melting the outer surface of your part. And it comes out looking, smooth and shiny, almost like an injection molded part. So that can be a really useful technique for certain circumstances. And even just when you 3D print an ABS part, it does have a very attractive surface finish. I would say more so than PLA, which tends to be a little glossy. It just doesn't look as nice to me. But it can be challenging to print. It has a tendency to warp. You have to make sure you're using the right kind of a printer setup and the right kind of adhesive on your bed, which we'll talk about. Might produce some fumes. I wouldn't be too concerned about printing PLA in my room, in my office. But for ABS, I'd probably want a printer with an enclosure and some filtration on it, just to be sure. There are some fumes going on there, some ultrafine particles, some what are called volatile organic compounds. Play it safe. Have some filtration. Have it in a well-ventilated environment. May not be suitable for prolonged skin contact, so if you're making something that's a wearable, I don't know if I'd use ABS myself, but it is one of the nice materials to work with. It has some nice qualities to it. Then you have TPU and other flexibles, but we'll talk about TPU. This is a great material because, as you can see in the photo, it produces nice rubbery, flexible parts. great for things like telephone cases or wheels that need to have a grippy surface, maybe parts on a drone, hinges that need to be flexible, all kinds of fun things you can do with TPU. It has great impact and wear resistance, great vibration dampening properties, as you can imagine. So if you have parts that you want to sort of provide some dampening between, you can have a part that you print in TPU that goes between them and provide some protection for that. Disregard the note here about e-Nable devices. That's from another presentation. As many of you know, I work with the e-Nable volunteer community, and that was a note from a related presentation I gave to them. Some of the negatives with TPU mainly is that it's very challenging to print. You have to have the right kind of printer. You have to have a printer that's able to print these flexible materials. Even a printer that has a Bowden tube type setup that I talked about before can print flexibles. There's different levels of flexibles, so you'd have to stick with things that are in the range of like shore hardness, 95A, maybe 98A, in that range. As soon as you get softer than that, like down into the 80s shore hardness, 80A, 82A, 85A, down into there, that's going to become harder and harder to print through a Bowden tube without a direct drive extruder. So that'll become a consideration. PETG is another popular material, growing rapidly in popularity because it's a lot stronger than PLA, but it's also environmentally friendly and non-toxic. It's fully recyclable. It has a much higher temperature resistance than PLA. This is what a lot of water bottles are made out of. It's quite a versatile material and has some nice properties to it. It can be more challenging to print, and it tends to have a bit of a stringiness to it. So if your printer is having to move kind of between parts as it's printing, there might be these little fine strings extending between those. You can get that under control using the right settings. I won't get into that today, but we have some of that guidance on our website, and you can get much better results if you do some fine tuning. Costs a little bit more generally, but not too bad. It's not too expensive. So really nice material. I encourage you to check out PETG if you haven't. Okay, so one note about our website, 3D Universe. If you haven't been there lately, if you go to shop3duniverse.com, you're going to see that we continue to expand our materials offerings, and there's a lot of materials to choose from. So to make it easier for you to find your next material, when you go to our materials pages, you're going to see that at the top you have all these filter buttons that you can choose from that have different kinds of properties. You can choose things like the physical properties that you want, or maybe a specific type of material that you're looking for. You can choose that you're looking for a certain size or something that might be flame retardant or wear resistant or whatever it is that you're looking for. And as you click these different filters, it'll narrow down the selection and show you those things that match those criteria. So really makes it easier to find what you need from the broad and growing selection of materials that we offer. So check that out. Okay, so now we have talked about the hardware. Now let's talk a little bit about the part design process, because this is the fun part of 3D printing. You have an idea and you want to bring that idea to life. So you have to go through this design process, and there's a lot that you want to think about that's going to save you a lot of headache later on when you get to the 3D printing stage. So when you're thinking about your part and your idea, think about some of these things. You want to think about the aesthetics. Does visual quality matter? Is this something that people is going to be sitting on a shelf and people will be looking at? Because that's going to give you input into how you design it, and of course when you go to print it, what material you use and how you slice it, et cetera, et cetera. Strength and wear. How strong does it need to be? What kind of environment is it going to be in? What sort of load is going to be applied to it? That's also going to influence your thinking about material as well as the designing and that sort of thing. What about accuracy? Are there going to be different parts that need to maybe fit together in a certain way where they have to have certain tolerances so that they'll move smoothly but fit snugly, and that sort of thing? Are there parts that maybe have to be split up because this is something that's too big and won't fit on your printer, so you have to print it in multiple pieces? That's something else you want to think about up front. What's the operating environment? Where is this going to be used? Will it be exposed to higher temperatures? Will it be exposed to different chemicals that might affect it? Would it be exposed to a lot of sunlight? Things like that. Ergonomics, does it matter what this thing weighs, how heavy it is? Does it need to be particularly light or heavier? Does it need to have a certain shape? Who's going to be using it? How will they be using it? That sort of thing. Post-processing considerations would be, is this something that needs to be able to be painted after I 3D print it? You might want to use certain types of materials then. Does it need to be sanded down or processed with a certain chemical? These are things that would also influence your thinking. And then again, assembly, is this something where I need to make it in multiple pieces and then put it together after the fact? And what kind of tooling and what kind of assembly process would I use? As you can see, there's a lot of different things to think about, and all of these things will have some impact on how you go about designing the part and how you go about 3D printing the part later on. So those are some topics to kind of use as sort of mental prompts for yourself as you go through this. One thing to think a lot about is the bottom layer. Whatever object you're printing, and we'll talk about orientation later, because you do have choices, of course, on how you orient your part to the build plate. But once you have it properly oriented, whatever surface is sitting on the build plate, that's really key. The way it's making contact with the build plate, and some of this is relevant to how you do your design. You want to make sure you have as much contact with the bed as possible. You don't want to have just a little bit sticking to the bed and then it's going off in all kinds of different directions. That's a hard part to print, and we'll get into some of that later. The more contact you have with the bed, the better. So think about that with your bottom surface. Try to avoid what are called fillets, where you have these nice rounded corners. They're beautiful. They look really nice. When you're in your modeling software, they're so easy to apply. You just click an edge and you say fillet, and you get this beautiful curved surface. And oh, wow, I got a fillet. You don't want those coming surface of the bed. You don't want to be building up off the bed on a curve like that, because it's right at the point there where it's coming off the bed. It's just such a steep angle. It's going to be messy unless you're doing, soluble supports and stuff that you don't want to mess with. So instead of doing a fillet, do what you see on the right. That's called a chamfer, where it's just at an angle instead of a curve. That's going to print much more cleanly, and it still gives you a similar effect. It still gives you a nice look, and it's a nice, finishing touch. On the corners, if you can, avoid sharp corners, at least, again, where it's on the bed. So think about where it's printing that base layer. Try to avoid having it do sharp corners on that base layer. If you can have a little bit of a rounded corner so that the print head goes around the corner instead of hitting a point and then turning direction, it's going to be less likely to peel up off the bed at that corner. So having a curved corner is helpful for that first layer. Tolerances, think about if you have parts that need to fit together, a 3D printer is only going to be able to print within a certain, range of tolerances. It can only produce parts that are so dimensionally accurate. So if you were to design a part where the parts in your CAD software fit perfectly together, where they have just a tiny fraction of a millimeter between them, let's say, 0.01 millimeters. That's good enough for CAD. There's still a gap, even if it's a small gap, right? If you 3D print those parts, they just won't go together. It's too close. You're printing with melted plastic here. You can only be so accurate with it. It's going to depend on your printer. It's going to depend upon your material, and it's going to depend on other variables. But in my experience, a good general range is 0.25 to 0.3 or 0.4 millimeters. So start there. If you design your parts with about 0.25 to 0.3 or 0.4 millimeters of space between them, print them out. They should fit pretty well and move pretty well. If not, you'll have to tweak it and go back and try it with a little more or a little bit less. But this is what I found is a good average to get you started. Okay, part orientation. Talked about this a little bit. You have to think about how you're printing your part. Are you printing it up this way, or do you lay it down on its side, or do you rotate it this way or that way? There's all kinds of different ways you can print any given object. Remember the way an FDM printer is working. It's going layer by layer, and it's building these layers on top of one another. Well, each layer that goes down, it's sticking to the layer before it, but only to a certain extent, right? It's the layer that went before has already cooled, it's already solidified, and then this new layer is going down on top of it. Yes, they're going to stick, but they are two separate layers still. And so parts will tend to split across, or along those layers. You'll have them split at those layer lines most often. And so you want to think about, where is your part going to be under the most stresses? Where does it have parts that are maybe extra thin that might be prone to break? And in those areas, especially, think about which direction your layer lines are going to be going. And if I turn it this way, then the layers are going through that part instead of across that part. That's going to give you better strength. I'll give you a demo of this once we switch into the demo mode here in a short while, and we'll look at some different examples of part orientation. All right, so now you got your part, you have it properly oriented in your slicing program, and now you have to start setting your settings, getting ready to 3D print. We're getting close to the exciting part here. So first question a lot of people think about is layer height. How thin should I be printing? You know, you can choose to print with, you know, 0.05 millimeters. That would be 50 micron layers. A lot of printers can go that thin. Or you can go much, much thicker. You could print with, you know, if you have a large enough nozzle, you could do 1 millimeter layers or 2 millimeter layers. You know, it depends on your hardware setup, right? The most common range for most printer setups using a typical 0.4 millimeter nozzle, you're typically going to be doing somewhere between 0.1 millimeter and let's say 0.25 millimeters. That's a typical range. So the thinner your layers are, the longer it's going to take to print, because you have to do more layers, but you'll have smoother surfaces. You'll notice, especially on the curved surfaces or the angled surfaces, that's where you're going to see the layers. A typical range, like I said, 0.1 to 0.2, maybe 0.25, if you want to do a quick draft print. The general rule of thumb is whatever your nozzle diameter is, your layer height can be up to about 3/4 of that nozzle diameter. So for example, with a 0.4 millimeter nozzle, your layers could be as thick as, let's say, 0.3 or so millimeters. You know, maybe even you could probably get up to like 0.32 or something like that. But as a general rule of thumb, think about 3/4 of the diameter of your nozzle as the maximum thickness that your layers could be before going to a bigger nozzle. So yeah, I mean, I typically use 0.15 millimeters as kind of my default. It's a nice high quality print, but not so thin that it takes forever. I find that to be a nice middle ground myself. Here's some examples. If you were looking at that 50 micron, really thin layer height that I talked about, so this is 0.05 millimeters. You know, if you look at the frog there, you can see that's pretty nice surface. This was done, I did this years ago on an old, very inexpensive flash forge printer, but really nice looking, right? I mean, you can barely see any layers whatsoever. You can hardly see the layering at all. Now, if I move up to 0.1 millimeter, this is getting into the range that's a lot more common. You know, usually you don't go down to that 50 micron layer height, but this is, I do pretty frequently print at this layer height, and still you can hardly see any layering. That's a really good look. I mean, we're zoomed way in here, and you can hardly see any layering. As I said, you can see it a little bit on the curved parts, like the eyeball there, and a little bit on the slanted areas, like the leg. That's where you can start to see the layering. But overall, it looks pretty good. Moving up to 0.27, now you can see the layering. Okay, we just made a big jump. There's a lot of ground in between there, but I just wanted you to see that when you go up over the 0.2 range, you really can start to see the layers. And if we just, you know, to give you an example of, you know, pretty much the thickest you could do with a 0.4 nozzle, this was a 0.34 millimeter print, and it was kind of just able to get away with it. And this is, as you can see, a pretty low quality print at that point. So that's kind of what to think about with layer height. You know, it's always going to be a balance of quality versus speed. You know, as you increase the quality, you increase the time that it takes to print, and as you reduce the quality, you reduce the time that it takes to print. So if it's something that you just want to do a quick first print to check something out, you want to do kind of a draft print, you can use very thick layers and very little amount of infill, and just you can get it printed very quickly. And then when you do your final print, you can choose much higher quality settings, and maybe it'll take 5 times as long to print, but that's fine, you know, because you know that you've gotten it to where you want it to be. Infill percentage. How much infill should I use? Well, how strong do you want your part to be? How solid do you want your part to be? If it's something that's going to sit on a shelf and people are just going to look at it, then you really don't need much at all. The infill is really just there to make it easier to print, so that you have something that's kind of holding up the walls and just to kind of make it easier for the printer to do its job. You know, you can get away with 5%, 10% infill. You know, it depends also on the size of the object. If you imagine printing something really large, then if you look at what you see there with 5 or 10% infill, that might give you enough internal structure for a larger object like that that's just going to sit on a shelf. If you're doing something small, like maybe a little miniature figure, then you're not going to want to use something like 5 or 10% because there's hardly going to be any infill in there in a small object. So you'd want to go something like in the 30 to 50% range probably. But then it also impacts your strength a great deal. If this is a part that's going to be under some stresses, I would say you want to be at least in the 20 to 30% range and probably somewhat higher. For a part that's going to really need to hold up some stresses, I would say you want to be in the 30 to 50% range. Past that, you really need to start thinking about the trade-off between strength versus weight. How much more material are you using and how much weight are you adding by going up to from 50% going up to 80 or 100%? Is it really giving you much more strength at that point? And is it really worthwhile to use that more, that additional material and take that additional print time and add that additional weight? It might be in some cases, but usually not. Infill style, usually you don't worry about this, just let your slicer pick the default. Usually the default is something like the hexagonal or the rectilinear or triangular, one of those that you see there. Don't choose something like concentric. It might look nice, but it's not as strong, because those lines aren't crossing each other inside. It's more of kind of an aesthetic thing that you might use for certain visual effects if you had a part that was open on top or something. I don't know, but I wouldn't use that for most uses. You want something where you have this kind of a grid pattern on the inside so that it gives you that strength and inner support. And then there's also the shells, the number of shells or the wall thickness. So your slicer might ask you to choose the number of shells, or it might ask you to specify a wall thickness in millimeters. So if it's asking you for the number of shells, that's dependent upon your nozzle diameter. So what you're looking at here was printed with a 0.4 millimeter nozzle. And what that means is that 2 shells is a 0.8 millimeter wall thickness. 4 shells is a 1.6 millimeter wall thickness, and so on. You get, I'm not going to do the math further here, but you get the idea. If you have a larger nozzle, that would be different. So if you want to specify it in thickness, you can just put in a millimeter value. You can say I want my walls to be 1 millimeter thick, and it'll figure out how many shells to do based upon the nozzle diameter that you're using. So you can do it either way, but this will affect the strength of your part along with the infill. So if you have a part that you want to be stronger, then you'll want to use it, I would say at least 3 shells as a guiding principle. 3 or 4 as a general rule is what I use for something that I want to have better strength. And you can see the reason for that here. You can see how that would, this is on all sides. This is the sides, the top, the bottom, everywhere there's a wall on your part would be this thickness. So it has a big impact on the resulting strength. Okay, supports. General rule, we try to avoid them if we can, but you can't always avoid them. A lot of parts can be printed without supports, but what we're talking about here is, remember, in an FDM printer, you're building layer by layer up from a build plate. And so you have to think about gravity, right? I mean, if you're building up and then all of a sudden you try to build off to the right side and you're trying to build over where there's nothing below it, and you're extruding melted plastic, what's going to happen? That plastic's just going to fall down to the build plate, right? So if you're printing things like that, if you look in the photo down here, if you're printing these 90-degree angle overhangs, you need something to support that. You need this kind of scaffolding that you see on the left side there to sort of build up and support it as it's being printed. And then you need to pull those supports off. You break those supports off at the end, or you can use a soluble support material, and then they can just be dissolved in water. But when you use the typical traditional supports, which are being printed in the same material as your object, this is what you would do with a single extruder printer. The supports are printed in the same material, and your slicer software generates these supports for you. You don't have to build these supports in your CAD software or anything like that. This is all done for you by the slicer. You just check a box to say whether or not you want supports. And it'll put them anywhere where there's an overhang past a certain angle, which you can specify. The default most slicers use is, I think, 45 degrees. That's typical. But I've found that most printers can get away with up to about 60 degrees overhang, depending on the material you're using. But in most cases, you can get up to about 60 degrees before you really are going to need supports. There's also something called bridging that you can use, and I'll show you that in a moment what that is. But the point is there's several cases where you can get away without printing with supports, even though you might look at your object at first and think you're going to need supports. You might not, so I'll get into a couple of those here. Overhangs. Again, you look at this object on the left. This whole thing was printed without supports, okay? And as you can see, it's going off to almost a right angle, and it made it. When you flip it upside down, you can see it started to get messy. But if you look at where that messiness really got started, up towards the top there, that aligns with what's around 65 to 70 degrees. So it made it pretty far before it really started to get some messiness on that undersurface. So it depends on what you're doing and how much you care about that undersurface and how clean that needs to be. That's what will guide you on determining whether you need supports there. I mentioned bridging. If you have 2 points in your object, like you see in that part there below, where the printer is going to have to connect between them, and those are 2 points at the same height, it can bridge between them. It can essentially stretch the material that's being extruded from one point to the other and connect it on the other side, and then it'll cool quickly enough that it doesn't drop down. And as you can see, the longer you go, the farther you try to bridge, the more you will start to see some like drooping at the bottom. You can see that on the red part. You can see it on the very top of the orange part or yellow part there. But you can, with smaller distances, you can get a pretty clean result. So you can do bridging as long as it's bridging between 2 points of the same height. Okay, so then there's things in terms of build plate adhesion. One of the things you'll have to think about in your slicer is how to get it to stick to the bed. There's something called a raft that you can enable. I don't usually use it just because I don't usually find that it's necessary. What it does is it puts, like you see in the photo, a raft under your whole object. It's printing several layers that are supporting your object. Your object is literally being printed on top of this raft. It adds to the print time, it adds to the material being used, and I just don't find it necessary in most cases. This was, I think when printers weren't as well calibrated and there were so many problems with bed leveling and build plate adhesion, this was a nice kind of workaround, I guess. But I just have not found it to be needed for the most part, at least nowadays. A brim I do use from time to time, and this is usually most helpful for the more advanced materials that tend to warp, off the build plate. So if you're printing with PETG or ABS or nylon, you might want to enable a brim. And what that does is it adds additional, lines coming out from the base that are connected to your object, as you can see in the photo there. And so when it holds it down, it holds it to the build plate and prevents your object from lifting. And when it's done printing and you take it off the build plate, you have to remove that brim, and you might need to kind of go around with an X-Acto knife or something to kind of trim the extra bits that are left behind. So there's a little bit of extra work involved, but not much. And it's a very reliable way of improving adhesion. But I will say, using some of the advanced adhesives we'll talk about in a short while, even this I usually find is not necessary. So usually what I'm using is an option called skirt. And this is where it just, at the beginning of a print, it's going to go around and extrude a ring or 2 rings or whatever you set it to around, the perimeter of where your object will be. And then it will begin printing your object. And these initial lines, the skirt, it's not connected to your object. They're entirely separate. It's only to kind of clean out the nozzle and make sure that anything that was in there so that the material is flowing smoothly and it's well primed, and you're going to be off to a good start on the object itself. And so when you take your object off, the skirt just comes off separately and you just throw it away. So this is what I typically print with. All right, how do I print faster? This is one question that came in about, if I have a part that I just really want to get done more quickly, how do I do that? Okay, well, there's a number of different variables that you can play with. There's your nozzle diameter. So go up to a larger nozzle. Instead of a 0.4, go to a 0.8 or even if you can get a 1.0 or a 1.2, there's all kinds of different nozzles out there depending on your printer and what your setup is. But again, going back to our guideline for the layer height, if you can go up to 3/4 of your nozzle diameter for the layer height, think about what that means here. If I go to a 1.0 millimeter nozzle, now every extrusion line is 1 millimeter wide, so I don't have to, I can do a layer a lot more quickly. Think about a lawnmower, you're mowing the yard, the bigger your lawnmower, the fewer times you have to go around. It's the same thing. So every extrusion line will be 1 millimeter wide, but also my layers can be up to, let's say, 3/4 of a millimeter thick. So I have far fewer layers to print to get the object done. So a larger nozzle can really help speed up your print because of that. Use a lower infill density. If it's something that you just need to get a quick print done, especially if it's something that's not going to be under a lot of stress, just lower your infill. If you go down from 20% to 10% infill, you've just cut your printing time probably almost in half, because that's most of your print is, a lot of your print anyway is going to be infill. And then you can set a larger layer height. Going back to the nozzle size, you can go up to about 3/4 of your nozzle diameter. So that's going to have a big impact on your print time. Thicker layers means shorter print time. It also means more visible layers, of course, but that's the trade-off. Okay, how to print objects with fine details. So let's go the other way. If we don't want to do a quick draft print, maybe we want the best possible that we can out of a printer. Maybe we want to print like a little figurine that has tiny little intricate details, and we want to get the best possible quality on those fine details. Drop down to a smaller nozzle. You can go to like a 0.25 is a pretty common nozzle size, a 0.25 millimeter, and you can get really nice fine details. You can even go smaller. On some printers, you can go, I've seen nozzles as small as 0.1 millimeters. But when you get that small, it really starts to become challenging because it's hard to push melted plastic through such a tiny, pinpoint of a hole. So it will start to get very challenging when you get really small. I usually don't go below the 0.25 myself, but a smaller nozzle will help you to print finer details. Use thinner layers. If you go to that 0.05, 50 micron layer height, or 60 microns, or 100 microns, 0.1, anything in that range, I'd say 50 to 100 microns is a really good range for a very high quality print. And maybe use soluble supports if that's an option. If you have a dual extrusion printer, you're going to be able to get a lot nicer detail if you're using soluble supports on certain surfaces, I should say. So if your object is like, if we're talking about a figurine here, that figurine is likely to have different parts extending in different directions that need to be supported. Where those supports connect to the object, if you use regular supports that you break away, you're going to have imperfections in the object surface where those supports were connected. It causes surface defects. But if you use soluble supports, once those supports are dissolved away, the surface is perfectly clean. You end up with a really nice smooth surface because of how those supports work. So that's another nice option if you have it. And then a really important tip that if you take nothing else away from this session today but this, it will have been time well spent. Always preview your G-code before sending it to the printer. Nothing's going to save you more time and more frustrations than this. And preview it in a specific way. Go to the preview mode in your slicer after you've set all your settings and you've sliced it, and you can scroll down through your layers, at least in every slicer I've seen, scroll all the way down to the first layer and look at that number one layer and how it's going to print. And I'm going to show you why that's so important in a moment here. So, having said that, let's switch over to demo mode. I'm going to get into a different screen here. Let's go to a slicer. Now I'm using Cura here. You may be using a different slicer, and that's fine. Most of them have pretty similar tools, pretty similar functions, so hopefully whatever I'm doing or showing you here, you'll have an equivalent in whatever program you're working with. But this is the most common one these days, so this is what I'll stick with. So let's just drag an object in here and see what we can look at. Start with an orientation and looking at part orientation. Let's say we wanted to print an object like this here, this large, some kind of a robot component. And I'm just going to kind of move it over here onto the build plate. And the first thing you're going to notice here is that it has this funny pattern on it. It's showing these slanted lines, and that pattern means that this is extending outside of the bounds of your print area, so you don't have a valid print here. So the first thing I need to do is rotate this thing, get it into an alignment that would actually fit on the build plate here. And now it goes to a different color, showing that we're okay. Now, how would we print this object? It's maybe it's a little easier to pull this up in a mesh mixer. I mentioned this program before. It's just a little easier to rotate around here and kind of look at it from different angles. Well, I mean, you could be thinking, well, maybe I want to print it sort of upright like this, where this side is on the bed. I see flat surfaces here. You want to have a flat surface on the bed. I could print it with this down, and then, it's printing this part up. You're going to need, it could print this angle coming up without supports, but you're probably going to want supports with this part across here because it's not, that's not a straight across. You got these teeth in here, so you're going to need supports in here. And I don't know, this doesn't seem like, I don't think you want that surface to be, having those imperfections that would come from those supports. If you keep kind of rotating around, you would eventually come to, I think, the sense that this is probably the side that you want to have down, because you have a flat surface that extends across most of the object. There is this kind of indented cavity in here, and we're going to need to use supports to fill that in, and we'll need supports to kind of hold up these shelves here, if you will. But overall, you've got this nice outline going all the way around here that gives you a nice flat surface on the bed. So, and that's what you're seeing here. So I think this is the way you want this oriented, so that side is laying down. The other benefit of doing it this way is you'll notice that in this case they have extruded text on the top, and they actually have a QR code over here. We want that on the upper face because it'll come out with the best print quality that way. Being extruded, because you can imagine these individual lines being extruded to make up that QR code, as opposed to trying to build them if they were like on the side of the object. You're just going to get a cleaner print quality this way with those details on the top face. So this is how I would print this one. And if we go ahead and slice now, I just have it on a draft setting because I want it to slice more quickly for the demo here. After you slice, you have an option to preview, and you see that button down here. Now, I want to point out a couple of nice things about Cure. It shows you an estimate of time that with your selected settings, it's going to take, this object would take 9 hours and 48 minutes to print. And it also tells you how much material is going to be used and what the cost is. And in fact, if you hover over this little eye symbol here, it breaks that down into some detail. It tells you where all the time is coming from, what it's spending on infill versus walls versus supports, etc. And it breaks down the material costs for you between your build material and your support material, etc. As long as you've set that up. You have to go into your Cura preferences and you have to enter the costs for the different materials because they're not in there by default. But once you do that once, then yeah, it'll give you an estimate of your cost for a print job. And then if you click on preview, it'll actually render these layers, and you can, like I said, scroll down over here and look at how your whole print is going to go, including your build material and your supports and everything. And what you want to do is go down to layer 1 and look at how that's going to go. You can kind of scroll around here and just look at that whole layer and how it's going to print. And you just want to make sure that it's making good contact with the bed all the way around. And in this case, we see that it is. Now, to demonstrate what I'm trying to show you here, I'm just going to quickly pull in a different object to demonstrate the other kind of case, something that's not properly set up. Let's pull in this model here. This is something that I was working with a colleague on. We're developing a sort of a vacuum formable type of a mask, and this is a mold that we're going to be using for that. And this was something that I was 3D printing for him. And I brought in the model. This is what he sent me, and it looks pretty good here. It looks like it's lying nice and flat. You got a flat surface down here, and builds up off of that. I see no need for supports. Looks pretty straightforward. I'm going to go ahead and slice. Oh, I will go ahead and turn off supports since we don't need that here. I will look into these. I'll get into these slicing settings in a moment here. I know we haven't gotten into that yet. I'm just going to turn off supports and slice for now. Everything looks good though at a glance. I mean, this looks like it should be an easy print. But if I go into preview here and go down to layer 1, look at that. That right there tells me that if I had gone ahead and tried to print this, I would have had a failed print. And the reason is that the bottom of this object was not as flat as it seemed. There was a slight curve to it. And so only the portion that you're seeing here in green was actually making contact with the bed. And then if we go up to level 2, whoop, there we go. See, it's printing out a little further, and 3, and 4. It's not until layer 4 here, move it back to 4, I guess I can just type it in. It's not until layer 4 here that it actually prints the entire layer. And what that means by layer 4, if we're using, what are we at here, 0.2 millimeter layer height, that means we're now 0.8 millimeters off the build plate. It's not going to stick. This is just going to be a mess. It's not going to print well. So in this case, you'd want to go back to your CAD software and flatten the bottom of that object. I will tell you as a quick workaround, if you just need to get this printed, you can select your object here, go into the Move tool on the left here on your toolbar. The top one is the Move tool, and you can just drop it down on the Z-axis. Right now we're sitting on the bed. Let's drop it down, say 1 millimeter. And now what we just did is it just dropped it down and kind of cut off the bottom of the object because it's going to ignore whatever's below the build plate. And if we just drop it down by that 1 millimeter and reslice it and go back to preview, you'll see that we're now going to get a good first layer just by having done that. So there's our layer 1 now. So now it's printing across the entirety of the object. That opening there is intentional. That's a slot. So yeah, be sure you check that first layer. It's immensely critical. Let's see, take a look at some of the other features that you have in your slicing program. And we are not going to be able to cover all this because we're already running long on time here. You've got lots of different settings to choose from. In the case of Cura, you have some kind of recommended profiles that you can use to get you going quickly, or you can go into custom mode, and here you have access to all kinds of different settings. I've already done a deep dive video on Cura that you might want to check out on our 3D Universe YouTube channel if you really like to learn more about the different slicing settings that you can get into here. But for now, I'll just point out that you have as much control as you would like to have over these different printing settings. So you can get into all that here, set up all of your different print settings, and then slice it, preview it, make sure it looks good, and then you can send it off to the printer. Another one that somebody asked about, I'll just show a couple of other quick examples here. Somebody was trying to print a chair, some pretty simple little object, right? Just this little, this is a little one that I grabbed to use as an example here. Now, this one was designed with these little feet here to make it easier to print. You have a little something that connects to the bed, and then you can pull those off afterwards. But, you know, if you look at this object, I'm thinking this is something that you could get away with doing without supports, because if you look at what it's doing, it's going to build up the legs, and then when it gets to these underside surfaces here that I'm pointing at, it can do bridging. It'll be able to bridge between the legs to print those, and then there's some angled surfaces on the inside there that it can build up. And then again, when it gets to the bottom of the chair, it can do bridging there on that flat surface. So you could do this without supports, but you might have some messiness on the underside. So if you want to have a really clean bottom surface, turn on supports. But you also want to think about the strength of this. You know, you got some really thin legs here, and if you do it this way, think about the direction of your layers. Your layers are going across here. There's a good chance that if this thing gets under any stress, including when you're trying to get it off the build plate, you might break those legs. Couple ways of dealing with that: use a stronger material, maybe use tough PLA instead of PLA, or use something even stronger than that, and that'll help it to hold together better. You could look at doing a different orientation, even though this is obviously set up to be printed this way because of those things on the feet. Just for example purposes, we could look at what happens if we sort of spin this around and lay it down on its back. Now, it's obviously not making great contact with the bed. You might think that's silly to do it that way. But if you have a dual extrusion machine, you could turn on supports, and you could print it this way with supports, with it being held up here and holding up the legs. But the benefit is, if I just slice it, I better turn on the supports so we can see it with that. I'll turn on supports real quick here. And then we'll reslice it again. But the benefit of what we're doing here, even though this might seem a little counterintuitive, is the direction of the layer lines. If you think about these legs, you're going to have layers that are going this way, and those legs are going to be a lot stronger as a result because the extrusion lines are going through the legs instead of across them. So if I go to preview here now, you'll see, oh, it sliced without the supports, but that's okay. You can still see the direction of those layers, especially if we zoom in. It's pretty clear where you're going to have a strength benefit because you've got the extrusion lines are just going all the way down through those legs. You want to have more infill than what I'm showing you here as well, but the direction of those extrusions makes a big difference. So having that dual extrusion capability and the ability to use soluble supports opens up options like this where you could orient an object in ways that you might not be able to if you were just printing on a single extrusion printer. So it gives you some more flexibility. And then, one other example of that would be some very complex objects, like I just grabbed one here that's a scan of a human hip, where you have no flat surfaces anywhere. There is no way you could orient this where there's something flat to sit on your bed. The only way you can print this is with supports. You could do this with traditional supports and just break them all away afterwards. You'd have a lot of cleanup work to do, but if you printed this with soluble supports, you'd get a much cleaner result. Anyway, look at it though. This is a big and very long print to do something like this. So that's just a couple of notes on that orientation stuff that we were talking about there. Let's see, I'm going to flip back over real quick. So I want to see if any new questions have come in here because we are running a little bit long. A couple things I didn't have time to mention during the live stream. After you get all your slicing done and you're ready to go to the printer, make sure you think about your adhesion that you're using on the build plate. These days there are some really wonderful adhesives available, even for the more advanced materials. So especially if you're printing on just a plain glass build plate, these adhesives make all the difference in the world. I especially love the Magigoo adhesives, which is something that 3D Universe offers. They have a whole line of different specific adhesives for different types of materials. but their original formulation works for a whole bunch of the more common materials. And it's just great stuff because it really helps your parts to stick well to the build plate so they don't warp up even the more difficult materials. But after the build plate cools, the adhesion sort of releases, and so your parts come off really easily. So I just love it. It's the only way I print these days. I always use some Magic adhesive. I just really love how it keeps the parts stuck on there while the bed's hot and then lets them go afterwards. Another thing that you want to think about is humidity. This is something that can really impact your print quality and your results. So some materials are a lot more prone to moisture absorption than others. Materials like PVA, nylons, and materials like that pick up moisture very easily. There's quite a few others, but those are some of the more common ones. And if they pick up too much moisture, you're going to have lots of sort of printing defects. You'll see, you'll get sort of like popping and hissing sounds while it's printing. You might see little steam escaping at the nozzle, and it's gonna lead to gaps and in your layering and surface defects and quality issues. So make sure that your filament is nice and dry. There are accessories such as the one that I'm showing here, which is the Print Dry Pro. This is their newest version. This is, again, something that we offer at 3D Universe, so check it out. We have these in stock. It's a great way of keeping your filaments dry, and you can actually keep them in this unit and feed them out of here into your printer so that you can keep them dry while they're in use. So it's a great little accessory to have. And an enclosed build environment can help, especially with some of these more advanced materials, PETG, ABS, polycarbonate, the ones that tend to warp more. You really want to have an enclosed build area for that if you can. That's going to help quite a bit. And here's just an example of one print that I had done a while back. On the left, you see it done with a spool of material that had taken on some moisture, and you can see obvious quality issues there. And over on the right, you see what a proper quality filament results in. A nice clean print, great surface finish. Okay, quite a few comments have come in here. A lot of these are comments. Let's see, screen. Okay, some of the comments about the video issues earlier. It's like cool 80s MTV. Okay, for printing on FDM for miniatures, what kind of nozzle material would work best? Okay, so we talked about that. Smaller nozzle, thinner layers, and ideally with soluble supports, you'll get much better result on those miniatures. Let's see. Yeah, so these it looks like a bunch of comments. I don't see any new questions. I think we've covered most of what I received ahead of this episode. So I think that's probably a good point to wrap here. Now, I know I didn't cover everything by any stretch. We will be doing a lot more videos, both as part of 3D Universe Untethered and just as part of our YouTube channel. So please check out our YouTube channel if you haven't already. Check out our blog, 3duniverse.org, and the graphic in the upper left for 3D Universe Untethered, to see all the other upcoming episodes we have, get recordings to past episodes and that sort of thing. Thanks for joining us, and see you next time. Bye, everyone.